Hi, today we're going to be looking at calculating pH. Before we can calculate pH, we must first understand what pH represents. So pH is a measure of how acidic a substance is. It is a scale that goes from 0 to 14. 7 is neutral. Anything less than, wait, that's the wrong sign. I'm sorry. Anything less than 7 is acidic. And anything greater than 7 is basic or alkaline. The pH of pure water is 7. So it is neutral. The pH of lime juice is 2. So it's acidic. The pH of household ammonia is about 12. So it is basic. Now that we understand what pH represents, let's get into actually calculating it. So the formula for pH is pH equals the negative natural logarithm of the concentration of hydronium ions. So this formula looks a little scary, but let's work a problem out so I can show you that it's actually not that frightening. Carbonated water has a hydronium ion concentration of 1 times 10 to the negative 4 power molar. What is the pH of carbonated water? So first, we need to recall what the formula for pH is. So pH equals a negative natural logarithm of the concentration of hydronium ions. We are given the hydronium ion concentration in the problem, so we can plug that into this formula and solve for the pH. So pH is equal to the negative natural logarithm of 1 times 10 to the negative 4 power. So to solve this, now you need to input this into your calculator. So you want to put negative log, open parentheses, 1, scientific notation, so that will differ calculator, negative 4 power, close parentheses, and the answer is 4. Each calculator is different, so you might want to look at your user manual on how to best input the information on the left side of this equation. So you get the answer of 4. So that wasn't too hard. Let's try another one. A solution has a hydronium ion concentration of 3.6 times 10 to the negative 6 power molar. What is the pH of the substance? Round the final answer to the hundredths place. Apparently articles were not included in this question. Then determine if the substance is acidic, basic, or neutral. So again, the pH formula is pH equals the negative natural logarithm of the concentration of hydronium ions. So knowing that, let's go ahead and plug in what we are given for the hydronium ion concentration. That's embarrassing. Actual values. So 3.6 times 10 to the negative 6 power. and then input that into a calculator. And rounded to the hundredth place, the answer is 5.4. Now 5.4 is less than 7, so the substance is acidic. So now we're going to look at solving for the concentration of hydronium ions when given a solution's pH. Before we can do this, however, it is important to actually understand what a logarithm means. So let's take a moment to look at that. So a logarithm is the inverse of an exponential function. So let's say we have the function a to the x power equals y. Now you can write this in logarithmic form. So when converting, you will have log, and this is very much like going in a circle. So you start with the base of the exponent, which is a. That becomes the base of the log. Could go and write the equal sign there, and then you're going to go around basically in a counterclockwise circle to this value on the equal sign, and that is going to be the value here on the log. So log of a, log base a of y and then finally, complete the circle, go around to the x, and that is placed on the other side of the equal sign. So a to the x power equals y in logarithmic form is log base a of y equals x. Now you can also take a logarithm and convert it into exponential form. So let's say you have log base b of y equals x. You can do the same circular motion. So start with the log base of b, and that's going to become the base of the exponent. Then circle around to the other side of the equal sign where you have this x, and that becomes the exponent. And then finally, this y becomes the value that b to the x power is equal to. So just to recap, when converting from exponential to logarithmic form or logarithmic form to exponential form, you're really just going in this counterclockwise circle. The final thing you need to understand about logarithms to be able to calculate the hydronium ion concentration given a solution's pH is to understand what a natural logarithm is. So a natural log is a logarithm with the base of 10. So log base 10. Now when I was showing you the formula for pH, which again is pH equals negative natural logarithm of the concentration of hydronium ions, you may notice there is no base on this log. And I referred to it as a natural logarithm. That is because it is understood that the base of this logarithm is 10. Anytime you just see a log that is log with no base, it is understood the base of that logarithm is 10. It is a natural logarithm. All right, so now that you understand what a logarithm is and what a natural logarithm is, let's get into solving hydronium ion concentration. The pH of a substance is 9.62. Find the concentration of hydronium ions of the substance. Round your final answer to 1 decimal place. So let's recall the pH formula. So we are given the pH, but we are not given the concentration of hydronium ions, and that's okay. We can still solve for the concentration of hydronium ions. So let's plug in our known values. So we know that the pH is 9.62. Then we're going to have negative natural logarithm. We do not know what the value for the concentration of hydronium ions is, so I'm just going to use x to represent that, and we're just going to solve for that variable of x. So the first step in solving this equation is you want to multiply both sides by -1 to get rid of the negative that is currently attached to that log. So then you'll have negative 9.62 equals the natural log of x. Then you want to convert this from logarithmic form to exponential form. To make this a bit easier, I'm going to rewrite this equation of the log of x equals 9.62. Negative 9.62, sorry. So again, it's a circular motion. And actually before we start that, I'm going to go ahead and write in that understood base of 10. So we start with the base of 10. That's going to be the base of the exponent. Let's put this in red. So you'd have 10 as the base. Then you circle around to the negative 9.62. So negative 9.62 is the power. And that's going to be equal to x because you'll finish circling around to x. So 10 to the negative 9.62 power equals x. So finally, you want to plug that expression into your calculator and figure out what x is. So 10 to the negative 9.62 power, and rounded to 1 decimal place, the value is 2.4 times 10 to the negative 10 power equals x. So the concentration of hydronium ions is 2.4 times 10 to the negative 10 molar. Let's try one more. The pH of a substance is 1.26. Find the concentration of hydronium ions. Round your final answer to the thousandths place. So again, pH formula. pH equals negative natural logarithm of the concentration of hydronium ions. So just like before, we can plug in our known values. So we know the pH is 1.26, so I'll plug that in for the pH. Then we have the negative natural logarithm. We do not know the value for the concentration of hydronium ions, so we're just going to use x for that. Just like last time, we want to multiply both sides by -1 to get rid of the negative on that logarithm. Almost ran out of room there. So then we have negative 1.26 equals the natural logarithm, of x. Then we want to convert this to exponential form. And before I do that, I'm going to rewrite it to make this a lot easier to see. once you get used to converting between logarithmic and exponential form, you'll probably be able to do it when the equation looks like this, but I'm going to flip the sides of the equation just to make it easier. So real quick, just gonna write in that understood 10. So starting with that 10, what's a color I haven't used? Orange. Yeah, let's do this in orange. All right, so then we're gonna have 10. And then you go up to this negative 1.26, and that's the exponent, so negative 1.26. That's gonna be equal, wow, that's a bad equal sign. Let's redraw that. There we go. And that's going to be equal to x. So finally, you just want to put the expression on the left side of that equation into your calculator. So 10 to the negative 1.26 power. And that, rounded to the thousandths place, is 0.055. Yeah, just 0.055 equals x. So the concentration of hydronium ions is 0.055 molar.